Okay, today starts 2.5 infinite limits and vertical asymptotes. So with infinite limits and vertical asymptotes, we're looking at a graph that is going to be going to infinity as we get closer and closer to a number. So in other words, we can get as high as we want by taking x close enough to 0. So no matter how high b is, the graph will always go higher. So no matter how high my point is here, my graph is always going to go higher as I get closer and closer to 0. Now that's going from the right-hand side. Y equals 1 over x is going to be doing that. So as I get closer and closer to 0, it's going to keep going up. Think about if x was 1/2. Then 1 over 1/2 gives us 2. If x was 1/4, so if this was 1/2, then it would give us 2 here. If x was 1/4, let's just make this 1/2, then 1 over 1/2 is 2. 1 over 1/4 is 4. And so the closer that I get, 1 over 1/8 will give us 8. If I go 1 over 1,000th, my y would be at 1,000. So the closer I get to 0, the higher my x is, or the higher my graph is going to go, as my x gets smaller. That would give us a limit that goes to infinity. So if I was looking at the limit as x approaches 0 from the right of this function, or of 1 over x, that's our function, it would go to infinity, because it would keep going higher and higher, never stopping, until I hit 0, of course, in which case it would be undefined. But again, with limits, we're not looking at the actual point, we're looking as it gets closer to it. If I look at it from the left side, 1 over negative 1/2 would give us -2. So it's going to be going down and just keep going down further and further. So the limit as x approaches 0 from the left of 1 over x would be -infinity. So this creates a vertical asymptote here, which we're going to get into. If I look at finding the limit as x approaches 1 from the right of 1 over x minus 1, and the limit of x approaches 1 from the left of 1 over x minus 1, my graph is going to look like this. It's going to be 1 over x shifted 1 unit to the right. And so I create this vertical asymptote, which that being the line that this graph gets closer and closer to as it goes to infinity. But it's never going to actually touch the line. It just gets closer and closer to it. That's our vertical asymptote. And so if I look at this one from the right, if I look at my limit as x approaches 1 from the right, my y just keeps getting higher and higher. So my limit as x approaches 1 from the right is going to equal infinity. If I look at it from the left, it's going lower and lower forever. So this is going to be -infinity. And so looking at the graphs, we can kind of see this. But can we just say that that's going to work every time? We'll get into that a little later. This one goes to -infinity from the left. So it's basically the same as the first example. Now we have two-sided infinite limits. So if we're talking about, sorry, just going back, if we're talking about a two-sided limit here, one goes to infinity, one goes to -infinity. So there would be no limit of the overall function here. limit as x approaches 1 of 1 over x minus 1 does not exist. Simply because it's going to infinity and negative to infinity depending on which direction I come from. Now, there is such a thing as a two-sided infinite limit. If we look at the behavior of 1 over x squared near x equals 0, then we're going to see an example where a two-sided limit occurs. So if I'm looking at this one, then no matter how high b is, the graph goes higher. If I'm coming from the right-hand side, it goes to infinity. If I come from the left-hand side, it also goes to infinity. So the limit of the entire thing in this case is infinity, because it's constantly going higher as x approaches 0, from the right and from the left. If I look at the additional example up here, 1 over x plus 3 squared near x equals negative 3. When I look at that graph, I can take the limit as it comes from the right. Limit as x approaches negative 3 from the right-hand side. 1 over x plus 3 squared is going to be infinity. If I look at it from the left-hand side, limit as x approaches negative 3 from the left of 1 over x plus 3 squared is also going to be equal to infinity. It just keeps going up. So then my whole limit as x approaches negative 3 of the equation would be infinity, because they both go to the same location. So these are kind of easy to see whenever we look at this, coming from the left and right-hand side. Now we'll move on to a different type, or a different way to look at them at least. So, whenever we look at these different types of functions, they can behave a lot of different ways as we get closer to their zeros in their denominators, like in this example here. So the first thing I'm going to do is I'm going to realize at the top, x minus 2 squared, limit as x approaches 2 of that. If I factor that out, it's x minus 2 times x minus 2. On the bottom, let's factor this out. X squared minus 4 is x minus 2 and x plus 2. Now, if I had plugged a 2 in here, that would have given us a 0 in the denominator. And we've seen this before. But in this case now, I can cancel this and this out. Now I take the limit as x minus 2 over x plus 2. That would give me 0 over 4, which would just be 0. And so by factoring that out, we could kind of see it. And that's something that we've done before. So the question is, if I look back at, say, my beginning function, 1 over x, that would have been 1 over 0 in the beginning as well. So just because it's 1 over 0 does not mean that I'm going to end up with a function that works or has a limit at all. It's all based on the different cases. In this case, we were able to factor it out and cancel and end up with 0 over 4, which was 0. in this case here, what could we do? Well, on the bottom is x squared minus 4. I realize my top is going to stay the same. That's x minus 2. Bottom factors out to x minus 2 times x plus 4 again. Those cancel out. So it's not x plus 4, it's x plus 2. Those cancel out. I'm left with 1 over x plus 2. And if I take my limit of that, limit as x approaches 2 of all that is 1 over 4. So I'm able to come up with a real solution there. Just because it looks that way does not mean it's always going to work. Let's look at this example here. Here I have x minus 3 over x squared minus 4. And I'm looking at the limit as x approaches 2 from the right. And so I can try to factor that out. But since we factored this out a couple times already, we should know that it's just going to be x minus 2 and x plus 2. And so as I'm looking at this, that's not really going to help. If I plug a 2 in, 2 minus 2 gives me 0, and 2 plus 2 is 4, I still would end up with a 0 in the denominator. But we're not looking for the actual point 2, we're looking at as it approaches 2 from the right. So if I'm looking at this as it approaches from the right-hand side, I could plug a number in for that's close to 2. I can start with x equals 2.1, right? So then 2.1 minus 3 on the top. That's going to give me negative 0.9 on top. On the bottom, 2.1 minus 2, it's just 0.1. And 2.1 plus 2 would be 4.1. If I do 0.1 times 4.1, that gives me 0.41. And negative 0.9 divided by 0.41 gives me negative 2.195 ... Think about if I plugged in 2.01. If I plug that in, up top, that's going to give me negative 0.99. On the bottom, that would be 0.01 times 4.01. Which give me 0.1604. And so my number on top got further down, my number on bottom got smaller. So I can expect my, when I divide those out, to be bigger. It's going to give me like 6.17. So this is going to, as I get closer and closer to 2, this is going to keep going further and further negative. So since it goes further and further negative from the right-hand side, it's going to be approaching negative infinity. If I look at the very same thing from the left-hand side, we can plug in, starting with 1.9, not 2.1, because we're coming from the left. Plug in 1.9. This factored out the exact same way, because it's the same problem. Plug in my 1.9. 1.9 minus 3 is going to give me negative 1. Can't really think this morning. Negative 1.1. On the bottom, 1.9 minus 2 is negative 0.1 times, and then 1.9 plus 2 would be 3.9. You probably see where this is going already. Now I'm going to have negative 1.1 divided by negative 0.39, which gives us 2.82. If I plug 1.99 in, it's going to be even further down. This would be like negative 1.01. And then it would be divided by negative 0.0199. Which is going to give you 50. .75. So you can see how much higher this gets. So my limit as it approaches from the right-hand side. I think that's actually a mistake. But it is going to be higher than the last one. Negative 0.1 times, and then would be 3.99. Yeah, it's going to be like 3 something. That seemed way too high. Because this wouldn't be negative 0.0199 down here. So if I do it that way, using what we like to call the correct way, this is going to give us 25.31. So it's going to be even higher, so this goes to infinity. That's what I get for trying to type it into my phone calculator. Since you guys left all the calculators in our, or all the batteries in our calculator stuff, so I guess I'll have to get those back online here pretty soon. So this one goes to infinity from the left. From the right, it went to negative infinity. So what would our limit of the whole thing equal? That limit would not exist, because they go 2 separate directions. So it seems like that's all we have. We have do not exist. It could go to a number, or it could go to positive or negative infinity. Which, if we look at this one here, 2 minus x over x minus 2 to the third. The first thing that I'll note is that I have a 2 minus x on the top. I'm going to factor out a negative 1. Limit is x approaches 2. Factor out a negative 1. And that's going to give me x minus 2. And now I have 3 of those same things on the bottom, so I can cancel 1 out with one of these. That becomes squared. I have the limit as x approaches 2 of 1 over negative 1 over x minus 2 squared. So think about plugging a number in here. If I plug in, say, 3.99, or I'm sorry, 1.99, then this is going to give us 0.01 negative squared, which is going to make this even smaller, which is going to make this actually go further and further negative. So we would be looking at negative infinity here. I can also figure this out just by looking at the graphs. as it approaches those points. Just like we did in the first two examples, where we just looked at the graph and we were able to determine that it gave us a vertical asymptote at those points. So that's our other method. Now we're going to get into precise definitions, and we will start that tomorrow. All right, guys, hope you're watching the video. Pay attention. It gets very similar to what we just did, so don't worry about it too much if you don't understand. If you don't understand, you could always come to class. All right, see you tomorrow.